Well, hello again. This is Mr. Ensler. Hopefully you have out your 7.2 note sheet. And today we're going to continue with talking about substitution to solve a linear system. But we're going to relate it to solving word problems. We're going to see why this is at all useful. Okay? We're going to look at an example. And in this first example, it says the admission fee at a small fair is $1.50 for children, but $4 for adults. Man, kind of stinks to be old, huh? Oh well. On a certain day, 2,200 people enter the fair, and a total of $5,050 is collected. How many children and how many adults attended? All right. Now you could sit there with your calculator and do some trial and error and plug in, all right, maybe, 1,000 children entered and 2,000 adults entered. I don't know. But that would take forever to try and figure out the right answer. So here's what we're going to do, and we're going to follow these three steps. We're going to assign variable names to the problem. So what do we want to know? We want to know how many children, let's call that C, and how many adults, let's call that A. So C is the number of children, A is the number of adults. And so then we're going to write two equations out of this. One equation is going to deal with money. And you're going to find this is a very common pattern in a lot of these word problems. There's going to be a money equation. So $1.50 for children. I'm going to shorten $1.50 to just 1.5. So 1.5 for every C that walks in. And we're going to add to that $4, or just 4 for short, for every A that walks in. And the money totals up to $5,050. So this is the money equation. Everything in this equation relates to money. $1.50 for each child plus $4 for each adult equals $5,050. All right, now we're going to have another equation, and it doesn't look like we have any more information, but, oh, what's this? There were 2,200 people, and so that is a total number. So I'm going to put that over here. This is going to be a separate equation. So we have a money equation, and then we have I'm going to say a number equation, if that makes sense. And what we're saying here is the total number of children and adults is 2,200. This is the equation that a lot of people forget about, even though this is actually the easier equation. All we're saying is the number of children, we said that that's C, plus the number of adults, we said that's A, adds up to 2,200. So that's kind of half of the problem, is setting it up correctly. Now we need to use substitution to solve. All right, so the first step in substitution is to get one of the letters by themselves. I would say let's either pick one of the C on the bottom or the A on the bottom. It doesn't really matter. Yeah, it really doesn't matter. Let's just do the C on the bottom so we all do it the same way. So I'm going to subtract A from each side. And you can put those in either order. Maybe I'll do 2,200 minus A. All right. And so then remember what you're going to do with that. You're going to take the other equation, the one we didn't do anything with yet, and you're going to substitute what C equals into that equation. So you're going to take this 2,200 minus A, and you're going to put it in for C in this equation. And so it's going to be rewritten 1.5, but instead of writing the letter C, we're going to write what C equals, which is 2,200 minus A. After you put that in for C, you got to go back and finish the equation. So plus 4A equals 5,050. All right, now we have an equation that we can solve. It only has one kind of variable in it. I suppose I should probably write all of these with capital letters. So we'll make this 4A with a capital letter. All right, so let's distribute, and definitely want to have your calculator out. If you didn't grab a calculator, go grab one right now. All right, 1.5, I'm going to type this into my calculator, 1.5 times 2200, and you get 3300. Make sure you are actually entering these in your calculator. Sometimes you might enter it in before I do and get the number first. Sometimes I might beat you to it. That's okay. But I want to make sure that you are actually entering this in your calculator so that you can get the right answer. 1.5 times minus a is just going to be minus 1.5a. All right, and then we just have the rest of this plus 4a equals 50/50. Usually when you use substitution, you're going to distribute, and then you're going to have some like terms to combine. In this case, we can combine negative 1.5a and positive 4a. If you want, you can type that in your calculator. Negative 1.5 plus 4, and you get 2.5a. And now it's positive 2.5a. If you're ever running out of room, you are always welcome to use another sheet of paper, like a loose leaf sheet or something like that. All right, now we're getting this equation down. We just have to get rid of the 3300 and the 2.5. So let's subtract 3300 from both sides. So we'll have 2.5a equals, I'll go ahead and type that in, 5050 minus 3300. Again, make sure you are actually doing this. Don't just wait for me or someone else to tell you the answer. When you take the quiz, when you do the test, when you take your final exam in a month, you're the one who's going to have to type these in. So make sure you get good practice doing that. All right, you get 1750. And so lastly, we're going to get a by itself by dividing by 2.5. These problems are kind of long. That's why we're only going to do 5 or 6 problems today, not more than that. All right, once you divide, you get 700. So that's one of our answers. And A was the number of adults. Okay, but we need to know the number of children. So we're going to plug this back into one of our equations. You can use either the first original equation, the second original equation, or I like to use this one where we got one of the letters by itself. And so when I plug that back in, it's going to be C equals 2200 minus A. And A is 700. So 2200 minus 700 is 1500. Hopefully that makes sense, that if the total number of children and adults adds up to 2200, and if we know 700 of those were adults, then 1500 were children. That also makes sense. It's a fair. There's probably going to be more children there than adults. All right, so let's label these answers and put it as an ordered pair. So we'll say 1500 children. So at some point we do actually want you to write this out in words, where you tell us the 1500 is not just C, but it's children. And the 700 is A for adults. So I want you to write that out and label it in words. All right. And that is our answer. That adds up to 2200. It also, if you plugged in 1500 for C and 700 for A in the first equation, it would add up to $5,050. All right, let's go to number 2. A hair salon receives a shipment of 84 bottles of hair conditioner to use and to sell to customers. The 2 types of conditioners received are type A, which is used for regular hair, and type B, which is used for dry hair. Type A costs $6.50 per bottle. Type B costs $8.25 per bottle. The hair salon's invoice for the conditioner is $5.88. How many of each type are in the shipment. When it says the hair salon's invoice, that means that's how much they paid for it. They're probably going to sell it for more than that, but that's how much they paid for it. All right, so it looks like we already have variables assigned, type A and type B, and we want to know how many there were. So again, one of our equations is going to deal with money. And so type A is 650 per bottle. So I'm going to write 6.5 times A plus type B is 825 per bottle. 825 times B, and they paid a total of 588 for that. They're obviously going to sell it for more than that because they want to make a profit, but that's how much they paid for it. Now the other equation is just going to deal with the number of bottles. It says that the total number of bottles is 84. And that's a total. It's helpful if you recognize that that's a total. Now, we don't know how many of A and how many of B, but this is going to be the simpler equation. Remember, you're usually going to have one that looks like this, where we're just saying the number of A bottles plus the number of B bottles adds up to 84. So let's go ahead and use substitution to solve this. We'll move the B over. You could also move the A over. Do it either way. You just want to get one of these variables by itself. So I'm going to write A equals negative 84, I'm sorry, negative B plus 84. All right, now we're going to substitute that into the other equation for A. So we're going to take that other equation and write it out. 6.5, but then we're going to substitute in for A, negative B plus 84. And then we still have to finish that other equation, plus 8.25b equals 588. All right. Now, when we substituted that in, it made it so that we have an equation with only one type of letter in it. This just has a B. So we'll be able to solve this. Okay, so distribute. 6.5 times negative b is just negative 6.5b. 6.5 times 84, I don't know what that is, so let's type it in the calculator. 6.5 times 84. You should get 546. I'll tell you what, the rest of that didn't really change, so let's just kind of leave it there instead of rewriting it. All right, so I can combine a couple of these like terms, negative 6.5b and positive 8.25b. So let's add those. Negative 6.5 plus 8.25, and you get positive 1.75. It's up to you if you want to put that before or after the 546. Doesn't matter either way. I'll just go ahead and put it in front. 1.75b, remember those have a b behind them, plus 546 equals 588. Okay, now there's just a regular two-step equation. We'll get rid of the 546 by subtracting it from both sides. So I'll have 1.75b equals, okay, 588 minus 546 is 42. So lastly, divide, well, lastly for this part at least, divide by 1.75, and the number of B types of conditioner sold is 42, divided by 1.75, 24. If you want, you can go ahead and just label that right here, 24 bottles of B. That's part of your answer, but we also want to know how many of the other type. But we've done almost all the work. All we have to do is just plug 24 in for B in one of our equations. I'll just use this one. A equals negative B, so negative 24. Even though our answer wasn't negative, there's a negative sign in this equation, so it's going to be negative 24 plus 84, okay? Let's just type that in our calculators. Negative 24 plus 84 is 60. So A equals 60. And what do we mean by that? 60 bottles of A type conditioner. So this is like the ordered pair. I'm just not writing it with a parentheses. You could, of course, but this is the ordered pair that tells you how many of each type was bought. Okay, on to number 3. We're just getting a tiny bit more difficult each time. We're showing you a new thing each time. All right, a political question. In 2004, 10 years ago, there were a total of 538 electoral votes available, and George W. Bush won 34 more electoral votes than John Kerry. An electoral vote is the type of vote that states get. Each state, the people vote for president, but then each state has a certain number of electoral votes. Some states that are bigger have more, some states that are smaller have less. And in total, across the country, there are 538. All right, and it looks like Bush won 34 more than Kerry. And that's all the information that we're getting here. It says write a system of linear equations, then find how many electoral votes each one won. So maybe here we'll start with the total number. And so you might just say, let's just say B for Bush. So the number of votes that Bush got plus the number of votes that Kerry got added up to 538. And you can see there's a bunch of different possibilities for how that could happen. But we know that George W. Bush won 34 more. So that's going to be our second equation. And this part, setting this part up, is going to be a little bit new for us. All right, we want to make an equation out of this. And so what we're going to do is we're going to put Bush on one side, Kerry on the other side. But the thing is, they're not equal. They did not have an equal number of votes. Obviously, Bush got more. He won. He got 34 more. So to make this an equation, you might be tempted to say, oh, Bush got 34 more, so we'll set that equal. But here's the thing. Bush already has more. This B number is already bigger. So if you add 34 to it, that's going to make it not equal. So we have a couple options here. To make these equal, you could subtract 34, and that would work. Or what you could do is you could add 34 to Kerry's total. Think about it like this. If Bush is 34 more than Kerry, if you want to even those out, you have to give 34 to Kerry, and then they'll be equal. All right? So this is our other equation. B equals K plus 34. I suppose you don't have to rewrite it, but I did. All right. And notice that one of these equations is already solved for one of the letters. B equals. So let's do substitution, and we're just going to plug in the K plus 34 for B. So I'll have K plus 34, and we got to continue that, plus K equals 538. So in some ways this problem is more complicated because we set it up a new way, but in other ways the problem is a little easier because the numbers, there's less numbers next to the variables. All right, so we're just adding here. I know it looks like we might be distributing, but we're not because this k is not timesing by the parentheses. So we're really just adding. So k and k makes 2k, and then plus 34 equals 538. All right, subtract 34 from each side. We get 2k equals, all right, 538 minus 34 is 504. And then we got to divide that by 2 to get k by itself. And so what's 504 divided by 2? 252. So the number of electoral votes that Kerry got was 252. So that's one of our answers. How many did Bush get? Well, Bush got 34 more. So you could just add 34 to that. That's fine. Or to use our equation here, B equals K plus 34. So K is Kerry, 252, plus 34. All right, so take your 252 and do plus 34, and you get 286. So Bush got 286 electoral votes. All right. So sometimes when you set it up and you know one is more than the other, you have to set them equal and then make an adjustment to that because you know they're not actually equal. All right, next problem. I think we're on the back now. Number 4. You enroll in a book club in which you can earn bonus points to use towards the purchase of books. Each paperback book you buy costs $7.95 and you get 2 bonus points. Each hardcover book you buy costs $22.95 and you get 6 bonus points. Your first order comes to $69.75 and earns you 18 bonus points. So just like the last 3 problems, we're going to set up 2 equations. And you have to decide kind of what those 2 equations are going to be. We're back to money, so one of those 2 equations is going to deal with money, and you might be able to tell the other of the equations is going to deal with points. And what are we trying to find out here? We're trying to find out how many paperbacks we bought and how many hardcovers. So each paperback costs $7.95. So I'm going to write $7.95 times P for paperback plus $22.95 for each hardcover. So $22.95 times H. And that total adds up to $69.75. All right. But we also have bonus points for each book that you buy. So for each paperback, you get 2 bonus points. For each hardcover, you get 6 bonus points. And on this order, you earned 18 bonus points. All right, so we want to figure out how many of each. So let's solve one of these for one of the variables. We've kind of gotten lucky the last 3 times where the last 3 problems where we kind of already had one of them by themselves, or we could very easily get that. Here, we're going to have to do that. So I would suggest we either want to get the bottom P or the bottom H by itself, whichever one looks easier to you. I think it looks maybe a little easier to get the bottom P by itself. So I'm going to add, or subtract 6H, subtract 6H to both sides. So I have 2P equals negative 6H plus 18. Or you could also say 18 minus 6h. That would work. Then we got to divide by 2. And so our new equation is P, paperbacks, equals negative 3h plus 9. And so what we're going to do with that, we're going to take that negative 3h plus 9, and we're going to substitute it into the other equation, the one that we haven't done anything with. We're going to substitute that in for P. So the other equation will have 7.95 times our p-value, which is negative 3h plus 9. Then we just finish out that equation, plus 2295h equals 6975. All right. Yeah, we got a lot of decimals going on here. So I know this looks really complicated, but we have calculators to help us out. So let's distribute to both of these. So I'm going to type in my calculator 7.95. Remember, don't be lazy. You should be doing this yourself to practice it. And if you get confused and you're not quite sure what to type in, raise your hand and someone can help you. All right, 7.95 times negative 3 is negative 23.85. The H is still there. So I should, again, probably just make these both capital. And then I also have to do 7.95 times 9. 7.95 times 9 is 7155. That one does not have an H right next to it. All right. You might be able to see that we can combine these two H's. One of them is negative, one of them is positive. So let's add those together. I'm going to type in negative 23.85 plus 22.95, and I get negative 0.9h. There's still an H with that. And then I still have plus 71.55 equals 69.75. That has not changed. And so now I'll try to get the h by itself. Right now h is being times by something and it's being added to something. So we're going to do the opposite. We're going to subtract 71.55. So I'm just going to get this ready here. I'm going to have negative 0.9h equals, all right, let's go ahead and type this in, 69.75 minus 71.55, and you get negative 1.8. And so then we're going to divide by negative 0.9. And h equals 2. So after all that work, we get a nice even number 2. That is h. So that's the number of hardcover books when a book first is published. It often comes out in hardcover. And then after it's been out for a while, it comes out in paperback. So to figure out how many paperbacks, we need to plug a 2 in for h, and I'll use this equation that I've already solved for. So p equals negative 3 times h, but we know h is 2 because we just figured that out. So negative 3 times 2 is negative 6, so then negative 6 plus 9 is 3. So 3 paper bags. Make sure you label these. These are word problems, so they represent real life things, and we want to label what those are. All right. Next up is number 5, and we have a lemonade stand. A child had a lemonade stand where large cups sold for 75 cents, small cups for 45 cents. On Saturday, a total of 78 cups were sold, and a total of $42.90 was what was brought in. How many of each cup were sold? All right, again, you might know the pattern by now. We have a money equation, and so the money equation is going to be 0.75 for each of the small cups. I'm sorry, 0.75 for each of the large cups, excuse me. So let's make 0.7 times L. We'll say L is large, plus 0.45 for each of the small cups. So I'll try to make an S here. And those two, this is the money equation, add up to $42.90. Now we also have another part to this, the fact that a total of 78 cups were sold. So this is just the number of cups, was 78. And so what we do there is actually much simpler, just the number of large cups plus the number of small cups equals 78. All right. Why don't you go ahead and solve this and see if you get it right. So don't wait for me to write it down. You go ahead and solve it. We'll take about 3 minutes, so if you can pause it, and then we'll come back. Okay, so we're back now, and you can see I have a lot of work on the board. If you're still finishing up, that's fine. So we set it up. I got the L by itself on the bottom. I'm not sure if that's what you did or not. So subtracted it over. And then we substituted it into the other equation. So 0.75 times negative s plus 78 equals 0.45s plus 0.45s equals 42.9. So then you actually combine like terms. And the like terms you're going to combine are negative 0.75s and 0.45s. And when you combine those, you get negative 0.3s. All right. So then you have to get that s by itself. So you subtract 58.5 from both sides. And now you have negative 0.3s equals negative 15.6. Divide by negative 0.3 and it equals 52. So s is 52 small cups. And then what you're going to do is you're going to take that 52, plug it back into one of our original equations. So that's what I did. L equals negative 52. The negative because that was already there. And so when you add those together, you get 26. So 26 large cups. Again, don't forget to label. All right, if we have time for this last one, let's keep it going. You're not going to have homework tonight, so let's keep going till the very end of class, until the bell rings. If we're running out of time, just realize that. Don't pack up until we're done. All right, number 6, your friends go to the snack bar and come back with food. One of your friends bought 3 hot dogs and 2 orders of fries. He said he spent $8.25. Another of your friends got 1 hot dog and 2 fries. She said she paid $4.75. So how much is a hot dog? How much is an order of fries? You really want to know because you only have a certain amount of money in your pocket. So you get out a piece of paper, a pencil, and a calculator, and you get to work. Again, we're going to have one equation dealing with money. And so for your first friend, 3 hot dogs and 2 orders of fries added up to $8.25. Your second friend, she got 1 hot dog and 2 orders of fries and paid $4.75. So I think this bottom H here would be the easiest to get by itself. By now you realize we're going to subtract the 2F over. So I'm just going to go ahead and write it. If I'm subtracting 2F over, it's going to be negative 2F plus 4.75. And then we are going to substitute that into h in the first equation. So we'll have 3, but instead of writing h, we'll write negative 2f plus 4.75. And we have to finish that off, plus 2f equals 825. And of course, then we will be distributing. So when we distribute here, we'll get negative 6f. And then we have to do 3 times 4.75. And you get 14.25. And then we still have plus 2f equals 825. So we have some like terms, just like a lot of the other ones that we've done. Negative 6f, and positive 2f. So if you add those together, you get negative 4f. So negative 4f plus 14.25 equals 825. From there, let's subtract 14.25 from both sides. So we'll have negative 4f equals, all right, I got to type in 8.25 minus 14.25. And I got negative 6. And then lastly, we need to divide by negative 4. You can see this won't work out evenly. That's okay. Negative 6 divided by negative 4 is 1.5. So that means an order of fries is $1.50. All right, and so then we're going to plug $1.50 into one of our equations. We can plug it into this one if we want. H equals negative 2 times 150 plus 4.75. Negative 2 times 150 is negative 3. Negative 3 plus 475 is 175. So a hot dog is 175. All right, if you're not gone already, I know you will be soon. So have a good weekend. No, or I guess it's not Friday yet. Sorry. Have a good day, and tomorrow you'll come back on Friday. We'll review. So have a good day.